Hello guys, welcome back to Statistical Academy. In this video we will be looking a simple SAS program to access data from a text file, commenting in the program, how the SAS system works behind the scenes, accessing raw data files, writing data lines in a program. Let's start with a simple program to access data from a text file and create a dataset. We have a text file with values represent gender, age, height in inches and weight in pounds. Each data value is separated from the next by one or more blanks. Now I have opened SAS Studio and I am going to create a folder here. Please click on Files and then click on this icon. Please click on Folder. Write a name of your choice and save. Please click on the folder you have created and click on this Upload button. Please choose your file from your computer and upload it. Now let us write a simple SAS program to access this text file and create a dataset called class data. As we have discussed in our previous videos, Datastep should start with data statement. Right click on the file and select the location along with the file name with extension. Copy this and paste inside the codes of Infile statement. Now I am going to give variable names in the input statement. Run statement ends this step. Let's select this part and run. Now let's examine the log. 17 records were read from the infile and the dataset work.class data has 17 observations and 4 variables. Okay. We ran the program without any errors and dataset class underscore data has been created with 17 observations and 4 variables: gender, age, height and weight. Now we will look at each statement of the program. In this program, the name of the SAS dataset being created is class underscore data. The next line, the infile statement tells SAS where the data values are coming from. In this example, data values are coming from the text file class, which is in the My folder of SAS Studio. The input statement written here is one of the 4 different methods that SAS has for reading raw data. This is list input method and it is appropriate for data values separated by delimiters. The default delimiter for SAS is blank. SAS can also read data separated by any other delimiters like commas, tabs or any special symbols, with a minor change to the infile statement. When you use list input method for reading data, you need to list only the names you wanted to give each data value. In our case, names for data values are gender, age, height, weight. Please notice the $sign following the variable name gender. The $sign following any variable name tells SAS that values for those variables are stored as character values. Without a $sign, SAS assumes values are numbers and should be stored as SAS numeric values. So here is the task for you to do at home. Please remove $sign and run the program. What would happen if there was no $sign here? Please try and comment whatever you experience. And one more task. What would happen if you submit a lab record without keeping headings of experiments? And how would it be to have phone numbers in our mobile without names? In real time, we should have a header to the program that we work on. The header of the program may have name of the program, where is the program located, purpose of the program, author, date of program creation, modification history. The statements beginning with an asterisk are called comment statements. They enable you to include comments for yourself or others reading your program later. One way of writing a SAS comment is to start with an asterisk, write as many comment lines as you like, and end statement with a semicolon. Comments are not only useful for others to read and understand your program, they are useful to you as well. Just imagine trying to understand a section of a long program that you wrote a year ago and now you need to correct or modify. Let's run this program and see. Now let us go to log window and check. 17 records were read. The dataset work.demographics has 17 observations and 5 variables. As you can see, now we have successfully derived body mass index variable, that is BMI. Now let's have a high level look at the program. This is called an assignment statement. It is an instruction to perform the computation on the right hand side of the equal sign. Assign the resulting value to the variable named on the left. Here we are creating a new variable named BMI that is defined as a person's weight in kilograms divided by a person's height in meters squared. BMI is a useful index of obesity. Medical researchers often use BMI when computing the health risks of various diseases. This assignment statement uses three of the basic arithmetic operators used by SAS: the forward slash for division, the asterisk for multiplication, and the double asterisk for exponentiation. At this point, please do not worry about mathematics. Everything is defined in an Excel workbook of instructions in real time. The same rules you learned about the order of algebraic operations in school apply to SAS arithmetic operators. That is, multiplication and division occur before addition and subtraction. In the table, the two highest priority operations occur before all others. The next highest operations occur before the lowest. For example, the value of x in this assignment statement is 23. In the second example, value is 35. Here is how. If you don't include parentheses in your expression, multiplication happens first and then addition happens. When you include parentheses in your expression, all operations within the parentheses are performed first. In this example, because parentheses surround the addition operation, the 3 and 4 are added together first and then multiplied by 5, yielding a value of 35. Another way to add a comment to a SAS program is to start with a slash star and end with a star slash. You may even embed comments of this type of comment within a SAS statement. For example, you can write like this. To truly understand the Datastep and take advantage of its many powerful and unique features, you must understand exactly how the Datastep processes data behind the scenes. The Datastep is not a mysterious black box. It follows a very logical process that is easy to customize to your data processing needs. The first important point to understand is that when you run a Datastep, it goes through two phases: compilation and execution. In the compilation phase, SAS basically prepares the code and establishes the data attributes and the rules for execution. In the execution phase, SAS follows those rules to read, manipulate, and write data. Now we will have a high-level look at each step. Let's look at the compilation phase. First, SAS runs through your program to check for syntax errors. If there are no errors, SAS builds a critical area of memory called the program data vector. The program data vector, or PDV for short, includes each column that you have referenced in the data step and its attributes, including the column name, type, and length. If this representation of the PDV looks like a one-row table, that's because the PDV is used in the execution phase to hold and manipulate one row of the data at a time. Also in the compilation phase, SAS establishes rules for the PDV based on your code. Which rows from the input table will be read into the PDV. Finally, SAS creates the descriptor portion or the table metadata. Let's go with an example. This data statement creates the output dataset demographics in the work library. To build the PDV, SAS passes through the data step sequentially, adding columns and their attributes. The infile statement in this program is listed first. It checks the input file and determines various attributes of this file. All of the variables mentioned in the input statement are added to the PDV along with the required column attributes like name, type, and length. If there are any other statements that define a new variables, those variables are also added to the PDV. In this code, the assignment statement defines the numeric variable BMI with a length of 8. Remember, SAS is not processing the data at this point. SAS simply adds variables to the PDV in the order they occur in the code. In this compile stage, no data is read from the input file and no logical statements are evaluated. Each line is processed in order from the top to bottom and left to right. Once the compilation phase is complete, it's time for the execution phase. In this phase, SAS reads, processes data in the PDV and outputs data into a new dataset. Datastep execution acts like an automatic loop. The first time through the datastep, the infile statement reads the file, then processes any other statements in the sequence, manipulating the values in the PDV. When SAS reaches the run statement or the end of the datastep then automatically loops back to the top and resets the values of the computed variables in the PDV to missing and executes the statements in order again, this time reading, manipulating and outputting the next row. The implicit loop continues until all the rows are read from the input table. I would like to show you programming process as an example of this compilation and execution phase, also reading raw data from files and data lines in program. These three topics will be covered in part 2 of this video because of scheduled interruption of SAS Studio in my region.